sketch the graph of the function f of x equals 5 times quantity x plus 5 quantity to the power of 6 times quantity x plus 3 quantity to the power of 7 times quantity x plus 1 quantity to the power of 4 on scratch paper. So graph it out on scratch paper is the recommendation, and then use that sketch to determine the end behavior and the zeros of the function, the multiplicity of each of those zeros, and the behavior at each of the zeros. Okay, so first of all, it's kind of interesting that they tell us to sketch the graph first, but if you actually follow these steps before sketching or as you're sketching, it'll help you create your sketch. So I don't think you necessarily have to sketch it out from the beginning. Let's go ahead through these questions here. The end behavior. First of all, how do we tell end behavior? Well, if it is an odd degree function, meaning the highest power on x is odd, then we will have opposite end behavior. And if it is an even degree function, then we will have same end behavior. So let's first find out if the degree of this function is odd or even. So if I were to multiply all of this out, it would take me a long time. But I do know that eventually, since I have 6 powers of x here in the first factor, quantity factor, and 7 powers of x in the second quantity factor, and then another 4 powers of x, I could, and all of those are going to be multiplied together, so we can add all of the powers there together to figure out the degree of this polynomial without actually multiplying it out. So I'm going to add 6 plus 7 is 13, plus 4 is 17. So this is an odd degree function. So that means I have opposite end behavior. Now that could mean that my two ends are opposite in this way, like down on the left and up on the right, or it could also be the other way around, where it's up on the left and down on the right. So how do we know which one it should be? Well, it's the lead coefficient. So you can just look at this 5 here and see that it's positive. And when it's positive, it'll be like when you have a positive slope on a line, the left end is pointed downward and the right end is pointed upward. From left to right, it's increasing if you just ignore what's happening in the middle. Okay, so then I can select my end behavior down on the left and up on the right. Now, we'll identify the zeros of the function. This is really easy to do because anytime you plug in something for x that makes one of these quantity factors zero out, it makes the whole thing zero out. And that's what we mean by a zero of the function. So I'm looking for the x value that will make everything zero out. And so there's going to be 3, one for each of these quantities. So for the first one, if you were to just set x plus 5 equals 0 and solve for x, that's a really straightforward way of figuring it out, even though you can probably look at it and figure it out without doing any formal solving. But that first factor, if I wanted to be able to do the workout like this, then I could solve for x by subtracting 5 on each side of my equal sign. And then I would have x equals -5. Okay, so -5 is one of the zeros of this function. And then if you continue to do that for each one of these quantity factors, you'll get all your zeros. So it's just the opposite. So instead of x plus 3, if I want to zero that out, I have to plug it in -3. For x plus 1, if I want to zero that out, I have to plug in a -1. Okay, so there are all my zeros. And now the multiplicities for each zero. So the multiplicity is the power on that quantity factor. So that's pretty simple. 6 for the 0 of -5 is with multiplicity 6. The 0 of -3 has a multiplicity of 7. Oopsie. The 0 of -1 has a multiplicity of 4. Right, so we're almost done. Now all we have to do is just choose what the behavior is for each of these at each 0. So for the 0 at -5, since it has an even multiplicity, I know that my sketch, well, Actually, this is probably a good time to do a rough sketch. So I'm going to go ahead and do that here. I need to see. So I had my zeros. I'll just go ahead and pause while I set this up. All right, so first thing is that n left is downward to the left, and the end on the right is pointed upward. Just having that as the starting point is, and we have a 0 at -5 right here. Okay, we have a 0 there. So what's going to happen is when I get that 0, I'm going to just touch or go through that. So even multiplicities, what I always say, we have another 0 at -3, okay? And so we see that the function we can see that but we turns around and that. And then what happens here when it comes back? And it's okay. Then we have another 1. So that's right about there. And turn around. Okay. So this is going to be very, very rough. Okay. Very rough. And we can get zeros. And we were asked to determine what was happening for 0. Okay. For the 0 and for the 0 1, it's okay. So let's back it. Here, here, and we. Right, and then this is excellent. Got a level of 3. Oh, did I choose the wrong? I can't tell if yeah, it looks like so I should have and here in let's try. Okay. Oops, I'm just gonna look at the okay.